Alright, what up? Welcome to this is a series, okay? So I'm gonna make videos on all of this. And it's Chemistry, Exam 3 for Dr. Schacht, Chapters 7, 8, and 9. And so, literally, I stopped paying attention after this unit, so it might be a little bit longer than what we hoped for. Sorry for everyone else to stay up. You can watch the review videos in the morning. Make your life a little bit easier. Anyways, so this is where we're starting off from. So I have ionic bonds and covalent bonds. Okay, wait, hold on. This is chapter 7 we're going to go over first. Types of chemical bonds, loose dot structures, bond energy. In this video, we're literally going over types of chemical bonds, bond energy, I think. And that's it. And then I'll go over Lewis dot structures and valence electrons. Why is Lewis dot structures on here twice? Whatever. Octet rule and formula charge and whatever. All of that. I do go over a little bit of polar bonds and electronegativity here. So maybe you didn't know. Okay. All right. Ionic bonds. Don't mind my gobstoppers. Okay. Ionic bonds, they take a lot of heat to separate. But that's just a note, just in case he has that on the test. All right. Ionic bonds are oppositely charged atoms that are attracted to one another. So it's positive to negative and they're attracted. So like NaCl, NaCl. Na is positive, sodium is positive, chlorine is negative. They attract together. That's an ionic bond. And they're held together by their charges. All right, covalent bonds. This is what we work with throughout the rest of the chapters, because that's what, those are the bonds that we're working with. So covalent bonds, they want stable full orbitals, just like ionic bonds. But we don't really look at ionic bonds. All right, if they can't steal electrons, then they share them for stability. So that's what covalent bonds do. And then for energy-wise, a covalent bond, when formed, energy is released. And that kind of looks like this. So this is the change in energy. And it's released, which means it's positive. So H2 is just 2 moles of hydrogen, and that is released too. And there's a chart that we're given that shows this. So when our bond is created, it's positive 436 kilojoules, and then energy is absorbed, which would be a negative, when the bonds break. And that's when the 2 moles becomes two atoms of, is that how that works? Yeah, 2 moles, 2 atoms, gas of hydrogen, and that's negative 436. So that's kind of how that concept works. Anyways, if you have any questions, message me. Or leave them in the comment section, because I'm a YouTuber. Just kidding. Okay, now this is kind of like where I got lost. So we have polarity, and so polar covalent bonds. So actually, we're going to go here. These are terms that you need to know. Ionic. Ionic bonds are when electrons are completely transferred from one atom to another. So that's when they're stealing and they take one from the other, and then they're completely stolen and they're their own. So it's like, for example, like chlorine, and chlorine will take an electron from another atom to get, because chlorine likes to be, chlorine has once eight electrons. So then, why Cl is usually negative. So Cl negative, well, that means that it's stolen an electron because now it's positive. And then sodium, well, sodium is usually Na plus, which means it has less electrons, which means chlorine probably stole its electrons. So that's usually why they're together, that's kind of how you can, explain that. Sorry, don't mind my record playing back. And then polar covalent. So polarity, polar covalent bonds are when electrons are shared unequally, which is usually what we work with. Kind of, but I'm gonna show you how to determine that. So unequally shared, and then he said polar neutral, but then that's literally not a term in chemistry, so I feel like he means nonpolar, because the opposite of polar covalent is nonpolar covalent. Whatever, I thought that was stupid. I even looked it up and it said that the AI was like, that's not a term used in chemistry. Anyways, electron shared equally. Okay, that's the basics of it, and then let's go into here. So, and then there's also a little bit of representation. So covalent bonds share electrons, but not always fairly. So when they're unequal sharing, that's polar covalent. And when they share equally, that's nonpolar. Okay. Representation in the media. Just kidding. Representation. This is how you're going to see these. So there's a partial positive charge, which looks like someone said delta, but I think it might be sigma. Anyways, this symbol, positive with this sign. So, for example, this is what it looks like. So hydrogen, and also hydrogen is on the furthest left side of the table. So this is going to get into electronegativity, which is over here. So if this is our periodic table, just imagine positive over here, negative over here. So if the atom is closer this way, it's partially positive, and the atoms over this way, it's partially negative. So sodium's on the left side, and that means it's partially positive, and chlorine is all the way over here, which means it's partially negative. So that's kind of what it looks like, because we have hydrogen all the way over here, chlorine all the way over here, partially positive, it's negative, partially positive, negative. Awesome. But how do we determine polarity? By comparing the electronegativity of the two atoms, which is what we just discussed. And electronegativity is the tendency of an atom to attract electrons. So going from no electrons to stealing electrons, or bonding or sharing electrons. So, and then this is kind of the key, and correct me if I'm wrong, but it's not on the, like, you need to have this memorized, because he's not going to give it to you on the exam, or on the sheet, which he doesn't. So make sure you have this memorized. These are the values you need to know for electronegativity. Nonpolar, 0 to 0.4. You need to have this memorized. Nonpolar, 0 to 0.4. Polar, 0.4 to 1.8. And then anything that's ionic is greater than 1.8. And this is the difference in electronegativity. This is delta. So difference. Okay, repeat with me. Nonpolar, 0.04. Polar, 0.4, 1.8. Ionic, anything over 1.8. So when you're doing this also, he's probably not going to give you one. Like, he told us. He's not going to give us one on the exam. That's 0.4 or 1.8. But these are the values you need to know. Okay. Now let's go over a little bit of examples. Oh, this is supposed to say something, and I can't remember what it is. Oh, partial charges. Pretend it says that, but let's go over here. So, these are our examples. I'm just going to go over one because you kind of get the point. Here's our compound. Nitrogen, that's what it is. Nitrogen and fluorine. Fluoride, fluorine. N on the chart. He's going to give you a chart. It's on your, here. This is the chart we're working with. Nitrogen, 3.0. Take my word for it. Fluorine, 4.0. That's what you're going to be given on the chart. You need to take the difference of them. So you're going to take F minus N. F minus N gives you 1.0. Remember your thing. Polar is, no, sorry. Well, it's polar covalent. So 0 to 0.4 is nonpolar. 0.4 to 1.8 is polar. What is this? 1.0. So it's polar. All right, so you kind of get the gist of that. These are just some examples. And then for partial charges, we're just going to use the same one. 3 for nitrogen, 4 for fluorine. Since this one is further on the left side, it has a partial positive charge. And since this one is, which also, it's less than, and this one's greater than, so this is going to have the partial negative, and this one's going to have the partial positive. Anyways, so that's kind of how that works. And if you need any more help, I'd look at electronegativity trends on the internet, and then it'll show, it's super self-explanatory. All right, leave any comments if you need help.